Today we're solving equations with variables on each side. The first thing we want to do when we're solving an equation with variables on each side is to move all of our variables to one side before we really start to do anything with the problem. Another thing we'd like to do also is if there are parentheses, we want to look to see if doing the distributive property would be the best thing to do. In this case, we're looking at 5a plus 2, and 5a plus 2 does not have any parentheses, but it does have variables on both sides. So what we're going to do is we're going to do the additive inverse of either one, and I'm going to choose to move the negative to the other side for positive. Again, it doesn't matter. And so we'll end up with 12a plus 2 is equal to 6. Now what's happening to a? A is being multiplied by 12, and then we're adding 2. So then we're going to subtract 2 and then divide by 12. So I'm going to subtract 2 and then have 12a is equal to 4. And then when I divide by 12, I get a is equal to 4 over 12. Now that's a fraction that must be reduced. And what I end up with is 1/3. Again, I'm going to divide both the top and the bottom of the fraction by 4, giving me 1 on the top and 3 on the bottom. Okay, so a in this case is equal to 1/3. So now we have another equation that we have to solve. This equation has a set of parentheses, so we want to do the distributive property. And so what we're going to do is distribute the 3 to both parts that are in the parentheses, and we have 8s minus 10 is equal to 18 minus 6s. Our next step is to move all of our variables to one side, so I'm going to move the negative to the positive. Again, I could have moved the positive to the negative, and actually I will do that just to show you that it's possible in both ways. So I'm going to subtract 8s on both sides. That's the additive inverse. I get minus 10. Remember, the sign goes with the number behind it. I get minus 10 and 18 equals 18, and then a negative 6s and a negative 8s. When I put them together is a negative 14s. Now I look at what's happening to s. Well, s is being multiplied by negative 14, and then we're adding 18 to it, remembering that this 18 is a positive 18. So what are we going to do? We're going to subtract 18 first, and then we're going to divide by 14. So when we subtract 18 from both sides, that's the additive inverse we're using, and so we get minus 14s on one side, and we get negative 28 on the other. We're going to divide by minus 14, because that's what we're supposed to do. And then when we divide by minus 14, we get 2 on the left, because a negative divided by a negative is a positive. And we get the multiplicative inverse, which cancels to give 1 on top and 1 on the bottom. So 1s is what we get for our answer. And that's how we know we finished solving. Okay, in this problem, we have 2 sets of parentheses. And we could do this 2 ways. We could distribute the parentheses and then divide, or we could divide and then do the distributive property. In this case, I'm just going to do the distributive property first. So I'm going to end up with 6y minus 30 is going to be equal to 20 plus 6y. I'm going to now move all of my variables to one side, so I'm going to subtract 6y. And when I do that, the additive inverse is canceled to give me 0. So I have minus 30, remembering the sign goes with the number behind it, is equal to positive 20. I know that this is always false, and I must write no solution. Again, no solution means the following: that there is not a real number that I can plug in for the variable y that would give me a true statement for this solution. Okay? It always will be false, and therefore I have to write no solution. In this case, we're going to examine a problem with variables on both sides, but what we're going to do is we're going to use a technique to get rid of the denominators. And you could do this without, you could solve it the same way we've been solving it, get common denominators, because that's the only way you can add and subtract, or add and subtract fractions. You have to have a common denominator. But I don't want to work with denominators. So what I'm going to do is I'm going to multiply everything on both sides of the equation by the common denominator. In this case, the common denominator is 4, right? And it's 4 because 2 times 2 gives me 4, and 2 times 1 gives me 2. And so the 2's are in common, So that's definitely part of my common denominator, and then I multiply by everything else that's left, which would be these two. So that gives me my common denominator, which is 4. Okay? Now, remembering what the equal sign actually means, if I have 5 on one side of my equal sign, and I multiply the left side of my equal sign by 3, then in order to keep the equal sign the same and balanced, I'm going to multiply the right side by 3. And therefore, I still end up with the same exact answer. So I'm going to use these two techniques of least common denominator and basically the property of equality to solve this problem and make it a little more simple. So what I'm going to do, since my common denominator is 4, I'm going to multiply every single term by 4. Every single term I'm going to multiply by 4. So every one. And what that does is it makes sure that I multiply everything on both sides by 4. And because I'm multiplying by the least common denominator, that should cancel out all of my denominators. So what I'm going to end up with is 4x divided by 2. 4 times 1 is 4. 4 times 1/4 is 4x over 4. And then I'm going to have minus, or subtract, 24. Now I said that the denominators should cancel out, and they will. 4 divided by 2 gives me 2 on top and 1 on the bottom. 4 divided by 4 gives me 1 on the bottom and 1 on the top. So when I rewrite this, I get 2x plus 4 is equal to x minus 24. And now I have an equivalent equation that I can solve and still get the same exact answer. Just like 15 equals 15 is basically the same as 5 times 3 equals 5 times 3, I get an equivalent statement that will give me the same solution. So now I have variables on both sides. I'm going to move all of my variables to one side by doing the additive inverse. And that will give me 1x. I have 1x plus 4 is equal to minus 24. What's happening to x? Well, it's multiplying by 1 and adding 4, so I'm going to subtract 4. When I subtract 4 on both sides, I get x is equal to minus 28. If I wanted to check this, I could plug in minus 28, and I should get the same answer. Okay? In this last problem, we need to really examine some vocabulary words and geometry. Luckily for this problem, our pictures are given to us. If we have an algebra problem where there are shapes and the shapes are not given to us, we should draw the picture. So it says find the value of h, or finding the value of h, it's important to remember what we're doing, so that the figures have the same area. So that means when I find the area of this triangle, which is 1/2 base times height, that should be equal to the area of this triangle, which will also be 1/2 the base times the height. So for the triangle that's on the left, right? The triangle that's on the left, the area is going to be area equals 1/2. Well, the base is 6, and the height is h. And so when I simplify that, I'm going to get the area of the triangle on the left, so I'm just put a little L so I know which one I'm talking about, is equal to 3h. The area of the triangle on the right, well, when I plug in, I have the area on the right, and that's going to be equal to 1/2 the base, which is 10, times the height. And the height in this case is actually an algebraic expression. It is it has two terms, and it has h minus 2. So I have to plug in both h and minus 2. That whole expression is what the height is. So when I do this, I end up with the area of the triangle on the right is 5 times h minus 2. And so I'm going to distribute to make my life a little bit easier, and that's going to give me 5h minus 10. Now, since I have 5h minus 10, I go back to my problem because I've now found the areas, and I have to know that the same means equal. So you're going to set the area of the left triangle and the area of the right triangle equal to each other. And so the area of the left is equal to the area of the right. And so I get 3h equals 5h minus 10. Now I have an equation with variables on both sides. I'm going to move my variables all to one side. And I get minus 2h, because 3h minus 5h is minus 2h, equals negative 10. I'm going to now divide by negative 2. Okay, I must divide by everything in front of the variable. And I get h is equal to positive 5. And if I plug back in positive 5, I should get 3 times 5, just to check myself. I'll do that in a different color. I should get 3 times 5 is 15. Okay, that works. And then if I do it on the other side, what do I get? Well, I get 5 times 5 minus 2, which is 5 times 3. That also gives me 15. So now I know that the areas are the same, and I've answered the question. The height is 5.